Today we're doing section 2.7 day 2, and again we're talking about polynomial inequalities. So we're going to be talking about rational equations today, so that's going to be dealing with fractions. So something you need to know is that denominators, so your denominator value can never be included in the solution even if the sign is a less than or equal to or a greater than or equal to. Okay, so I'll show you what that means kind of in the next example. So for this problem, again, you got to kind of follow the same steps as before. I need to get this equal to 0, so I'll subtract that 2 over. So I have x plus 1 over x plus 3 minus 2. We have to get common denominators, so I'm going to multiply top and bottom by x plus 3. So we know the denominator is going to be an x plus 3. I'm going to kind of skip that step. My numerator will be x plus 1 minus 2 times the quantity of x plus 3. So we will have to distribute. So I'll have x plus 1 minus 2x minus 6 all over x plus 3. So combining like terms, I get negative x minus 5 all over x plus 3. And that has to be greater than or equal to 0. So as far as getting my two zeros, I would set the top and bottom equal to 0. So from the denominator, I get x equals negative 3. And from the numerator, I would add 5, but divide by a negative, so I get a negative 5. So these are my two values on my number line. Again, let's put a 0 over here just because we'll make this be negative 3, 4, 5. All right, so as far as what we discussed, the negative 3 has to be an open dot because I can never divide by 0. If I use the negative 3, my answer would be undefined. So that's why I can never use it. However, because there's an equal to, the negative 5 solution will be a closed dot. So now I've created 3 regions to test. So I'm going to check negative 6, negative 4. So we'll check negative 6, negative 4, and a negative 2. As far as the check, I'm just going to go back to the original. So if I test negative 6, I have negative 6 plus 1 over negative 6 plus 3. And when I do that, I get negative 5 over a negative 3, which is equal to a positive 1.6, but that's not greater than 2. So that one's out. That's false. Now we'll check a negative 4. So I have negative 4 plus 1 over negative 4 plus 3. So I get negative 3 over negative 1. 3 is greater than or equal to 2. So in between works. That's true. And let's check a negative 2. So I have negative 2 plus 1, negative 2 plus 3. In the numerator, I'll get negative 1 over a positive 1, which is negative 1. And this is not greater than or equal to 2. So my answer is only one region. If I write this in interval notation, it's from negative 5 to a negative 3, parenthesis on the negative 3. Because again, that cannot be included because I would get undefined. Alright, so that's all for today. You have a practice problem to try. It's a little bit easier because you don't have to get common denominators. You already it's set up for you, just already go into the number line process.